Hello and welcome to another presentation on our Today BA Excellence Community Conference. I hope you are enjoying the presentations that we have prepared for you so far, and I hope that you are waiting in the anticipation for the next topic and the next presenter. Regardless whether you are watching us in the morning, in the evening, in the afternoon, I hope you are having a great day. And I hope that the presentation is meeting your expectations. Our next presenter, who will have the opportunity to share the topic about best practices on how to conduct the discovery phase for machine learning project, is Anastasiia. Anastasiia, hello, welcome. So happy to have you as part of our IT conference. Could you please tell us a bit about yourself, present yourself to our audience so that the audience who will be watching the presentation will get to know you as the specialist in the topic of the machine learning?
Yeah. Hello, everyone. And our topic today is best practices, how to conduct the discovery phase for machine learning projects. We will go through specific of machine learning project, discovery phase, best practices, and conclusions that we will do in the end. And about myself, I'm experienced business analyst with over 8 years of experience. Also have master's degree in computer science. And second, my master's degree in law, and also I'm doing a PhD in computer science already 30 years, and especially my topic is machine learning, so have a lot of experience with machine learning as developer previously, because I started my career as developer after growth with startups and with our team, and already was manage and lead our team. And after that, I decided to take role of business analyst, because I'm like a bridge between our awesome team and stakeholders, clients. So probably we can go to the next slides. Why machine learning is the future. And here you can see the answers from ChatGPT. So it's already machine learning can answer to this question. And here we can see that ability to analyze massive amount of data, increase it automation, improve accuracy and efficiency, wide range of application. Overall, the ability of machine learning to analyze large amount of data, automate tasks, improve accuracy and efficiency, and have a wide range of application might make it promising technology for the future. And it's really true. And we can see that, for example, such ChatGPT, it's natural language processing model that using for that usually. It can be different type of models and projects that you will see inside machine learning. And it's good example why it's the future. And next slide, we are going to see the circle of machine learning project, how it's going, which stage we have, and how we will go deeper to each of this stage. First of all, it's defining the statement of problem, understanding business needs, and define the scope of minimum viable products. And here you should pay a lot of attention to the customers' needs and define which metrics will be mean for them successful. It's from business perspective, and as well from defining minimum viable product, we should pay attention to the technical part. And also already on the defining the problem statement and defining all business needs, you can think about which metrics will be successful, which accuracy should have our model, which KPI for them will be good one from the business perspective as well. And the next stage is prototype, when you're going to receive data and get data. After that, you're working to prepare such data and train model, evaluate model, and after we come back to the get data. Because usually our models should be iteratively learning. So we are receiving new data, so we can make new circle and relearn our model, or it can be make it automatically if you write for that special use for that special tools, or write it in your model that we will take data some time, for example, per week from our database and to reuse for relearn model, and also set up time when it will be coming. So it's like small circle inside our big circle of each machine learning project. And after that, we are going to the production. Here, very important to think about infrastructure and understand which tools, which product, which performance you would like to achieve. Because when we, it's a lot of solutions presented by Amazon, Google Cloud, Azure that can help you with services that will help you to deploy your machine learning model. Also, here important to calculate cost, measure which performance do you would like to have, how it will be going, and also already on the discovery phase, it makes sense to think about such part. And after we go to measure quality of our prediction, measure how good our model works from both perspectives, from the technical one and from business needs as well. And here we can go directly to the discovery phase. Why it's important? It's here we collaborate with our stakeholders. We collecting all data about the project. We have collaboration in team, and we setting our team. We on such stage we should understand who we will need in the team, and also work on onboarding such person and start collaboration, research. And especially for machine learning projects, it's very important phase because here we need to already start with research, already think which data we will have, how we would like to collect such data. Sometimes it can be different sources, and we will need to normalize such data to the similar types, or to normalize or to use different techniques to collect or make our data set more bigger. So also we should think which efforts will be, also think about technologies that we would like to have, and of course collaboration with our stakeholders and clients, and think about their needs. And it's also why it's important, because it's the base and foundation of all of the project. And benefits of discovery phase. It's reduce the risk because when we already understand, for example, we can be not be sure for machine learning which model we will take, but we already can set up the list of models that we would like to try for this one and make some first experiments use test data and start experiments with that. And we will understand which of such model will be better for us. Probably it can require a few circles, but it will be definitely very useful for your future work. So it's reduce the risk that you will go the wrong way after, and also it's establish a roadmap so you can understand the phase and how your project will go, and build trust, regular communication, and in-depth discussion, establish trust in the team and in your collaboration with client stakeholders. And here you can see the best practices for conducting the discovery phase for machine learning project. First of all, it's defining the problem. And in the nearest slides, we will go deeper for each of that and with real examples. Define the problems, it's identify the problem you're trying to solve and desired outcomes, gather data, and we should understand sources where we would like to take such data, how it will be stored, if it will be video, images, or it will be some CSV file, or it will be different database, or we would like to collect it or combine some way. So here we should think about our data and how we will collect it, how we will process with it, and analyze our data to identify patterns and trends in this data. Also, we should understand which parameters will be important for us. After that, we can, in the latest phases, we can add some parameters, but the basis, how we will, which inputs will be to our models, we should understand from the discovery phase. Yeah, and of course, we should, when we go into the model, we should understand which type of the project it is, because it can be natural language processing, it can be recommendation system, it can be different types of the projects that all inside machine learning, and depends of it on each of such area. You can research and choose for you a few types of model and try to use different inputs, different amount of layers in your model, and already understand which of them you would like to use for research for the nearest phases. Yeah, and I hope they are following these best practices that I'm sharing with you and will continue to share in the nearest slide. You can ensure that machine learning projects are successful and efficient. So we can go directly to each of such practices more deeper. And first of all, it's defining the problem statement. So it's when we understand all needs, defining means first document where we're describing what we would like to achieve, which metrics we would like to have, all requirements from our stakeholders, how they would like to see it, which metrics will be from the business perspective. Because our models can be works well, but depends on which part of application we will take it. It will be have different impact to the end product. So if it's goal to change flow of the customer, or its goal to achieve some additional revenue, we also should put it in our requirements and validate it at the end, or we achieve it or not. And here I would like to share with you a real example, one of the projects where I work. So here I will share best practices, and after we'll go on the example of this project, how it's going in real. Yeah, and it's information support system for people with visual impairments based on millimeter radar and with help of vision. It's like our problem statement. With the help of vision, a person received more than 80% of information about surrounding world. So it's very important. And here on the slide, you also can see the amount of people who have such problem, and it's a lot of. And using such radar, we can help them and also provide such information to them about obstacles that they see on their road. And also such radar was very popular to automated cars, but it wasn't used never for people with visual impairments. And it's social, and also he had a little bit different algorithms that we can, and neural models that we can use for that, because we can receive just data, and depending of it, and it's different obstacles that usually, for example, car taking and and people takes on their road, and object. So it's process of recognizing object in system of detected interference, and the method of using such microwave radar in the interference detection system and obstacle detection system. The goal is to increase the performance and accuracy of detect obstacles. And also, when we already go into the problem statement, we can think which tools we will use. And because it's hardware and software project, we think about both sides. And here you can see that why we choose definitely this radar, and it's also have already inside some microcontrollers that can provide you data in specific different formats. And also it was a challenging part to take which of this data will be more useful for us. And we, on research phase, we a few times changed it because we can receive just signal, we can receive heat map, we can receive different types, different data that such radar taking. And also here you see that why we choose it. Here different metrics that we calculate, like range accuracy, angle, speed, if it can measure the speed, because for example, if a person with visual impairments will be stay on the zebra and it will be going car, if it will be object with some speed, we can say that it's car or it's bicycle, and also we can, depends of our heat map, say it. So it's have good potential on it. Also works in the light, because some of cameras, it's medium one when medium accuracy when we are going to the dark. For laser it's very poor, for infrared also medium, and radar, for example, have very good accuracy when it's dark. So it doesn't matter if it's dark on the street or not, or it can be rain or it can be snow. It doesn't make matter for these things to calculate all other things. Measure speed, measure range to the objects, measure which type of the obstacles on the way. So already from the statement, you can have some research that will provide you that you choose this to use and you choose such technologies. So it will be nice to do from the discovery phase. And best practices will continue, and next part related to the data. And here we need to identify the data sources that we will need to use, collect and preprocess the data, and of course explore the data. And here I will go also to the examples. It's data parsing that we received from such radar. It was different frames that have, so it's sending data by frames, and each frames have TLV. So T is mean type, L mean length, and where its value. So in each frame that we are receiving, we have firstly type and length of data that we will receive after we're receiving such data, and after its next TLV coming. So it's such radar and working in real time, and we're receiving data like each millisecond. And it's a lot of data that coming, and we should very fast react to that. Very fast react if it's wall closer to such person, or it's glass door. So we can go to the next one. Such TLVs in the common, giving us matrix, range azimuth head map. And such matrix showing us that we can scan in real time our space by 60-degree in each direction, and also it's have you can change position of such radar, but it have 120 by 1 horizontal, or for example, for horizontal, and for other direction it's have 60. So you can choose how you would like to scan space, and also you will see, so you can, it's the same time you're receiving you're receiving a lot of matrix that in common making you the space head map. And also each row giving us the range. So up to 11 meters, we can see very well what's going closer. And here we can go, it's also the vision of such matrix, but it's more useful like for persons, that we can for each direction to see like minus 60 degree, and to the other part also 60 degree. And here we can see the range to the object, how far away it's from the person. So can talk a little bit more about such data collecting. Also, we was decided which obstacles we would like to choose for first launch, and for that it was necessary to create data set fully by our own, because the similar data set wasn't presented anywhere. So it was created special script that giving us such matrix very faster, and making a lot of experiments to receive it. And also was it was scripts that we are taking our radar, going to the different, for example, stairs up and stairs down, scanning the space and receiving data from different obstacles in different spaces. We have done such experiment, and in the end we're receiving a lot of data, and also we was receiving it's very fast. So we make it that we're receiving each millisecond different or few milliseconds. It was very, very fast. Then we also can set up it on our script how many we would like to have. And for example, from one, it was very good for in such direction, because for example, when we're collecting data for the stairs up, from the just one stairs, just a little bit changing and direction and how we see such stairs from the radar, it was a possibility to receive more data. So it was already the similar stairs, but from different perspective. And of course, it cannot be just one stairs that you will use, because in another case, your model will be very great to understand this stairs or very similar one, but different one will be already worse, because someone can be like circle or spiral doing. For example, if we're talking about stairs, so we should use different types, and then more different and biggest difference they have between them, it's then better data set you will have. And here we can go to the algorithms, select machine learning algorithms, split the data for that. We're always having training data set, validation, and test data set. So training data set is used to train the machine learning model. The validation data set is used to tune the hyperparameters on the model. And the test data set is used to evaluate the performance of the model. Most part of the data going to the training data set, and the rest we are splitting between validation and test data set. And it's very important to think how you will split it, because, for example, if you have different classes like stairs, wall, glass that you would like to detect, each of such classes should be presented on all data sets. And probably on training, it can be about 80% of data to train your model, and the rest you can split between validation and test data set. Yeah, and in the end, you can build a baseline model, or of course, from the start, you can have not all necessary data, or it can be in the progress with collecting, but will be awesome if you can set up collecting the data from the discovery phase, because when you will go to the already set up model experiments, you will have all such data and you will be able to use it. You will be not need to wait to understand real quality of prediction for your model. So here we can go to the real example as well. So for our obstacles detections, we was use convolutional neural network. It's also very popular to use when some images you classifying. Why? Because why we use it for our case as well. We're receiving such head map, but we're receiving its different type data. We was need to normalize it, and after that we was have head map, and in such head map it's very in real similar to the image, but in binary type. Because here we can also scanning space and we understand where some obstacles in our way. And also depends of, because such radar working that it's sending signal and receiving such signal back. So depends of how big such signal. We can understand that it's, for example, glass door, but it's not a wall. So we can say that it's glass on your way. It's not like wall, or we can. And also, it's very important with glass because people who have some problem with vision, or sometimes just usual one when we go into some city mall and it's fully glass door closer to us, we don't see that it's some obstacles on our way. And such things always will tell you that it's on our way. And yeah, we also use such type of neural network because depends of, yeah, we also try to use, as I mentioned, different types of data that we can receive from such radar. It was signals vision, it was by just not had maps fully, but some anomalies that we have. And we try to use different type. We have a lot of experiments with that. And in the end, we decided that such head maps will give us most information. Of course, it was need to normalize such data collected, but it was most useful, and we can scan space very well. So technologies that was used, also, as I mentioned, we should think about it from the discovery phase. And for us, it was Python, Raspberry Pi from its microcontroller that was additional microcontroller, because such radar have one already inside that can send you data, but for process it and have our script and to use Python, it was very useful to have Raspberry from hardware side. And TensorFlow and Keras also was used. And next one, it's iterate. Iterate on model, validate our quality of the model, and probably we can make a few circles to receive achievement goal, because you can see that some additional parameters can have impact, or you would like to add new data to your training model, then you will need to relearn your model and come back to that. And also, of course, all such experiments, all such work should be documented. So you can pay attention to document from the discovery phase, and especially on discovery phase, because discovery phase on machine learning, it's take more effort than usually on other project, because here you have a lot of research. You should understand data sources. You should already think about data preprocessing, algorithm selection, the model performance. So to analyze it, you can start from the discovery phase, and of course all such experiments that you will do and why you will choose such technology you should collect, because sometimes you can have chance to come back to the previous year experiments and experience and decide that such one for example have very good performance, but we would like, and prediction make us very great prediction and it works well, but cost of deployment, for example, too high, and we can use very similar one but from with a little bit less cost, and how we can control it, because for especially for enterprise projects it's very important to understand from both perspectives, from the your end customer needs, from business needs, from clients needs, and understand the metrics that you would like achieve from the technical perspective. So I would like to say that it's critical step in any machine learning project. And here I would like to give you example with metrics that we are using. So it's confusion matrix. You can use it to validate your currency and your result of prediction. Here you will see that it's showing you how good it's in prediction. So true positive, it's, for example, we will take some example with wall. If wall this recognition right, so it's true positive. Recognize right, then it's true positive, so it's wall, and we understand that it's a neural network also understands that it's wall, then it's true positive. When it's wall and it's decided somehow different, let's say not wall, then it's no when it's wall, when it's false positive, so it's positive false positive wall. So our neural network saying you that it's wall, but in real it's not. And the similar ones for negative. And when we going here, this example of real how we detect such different obstacles types. Here you can see like true value and neural network result, and you can see that walls that was by neural network recognized correct with more than 200, and some part of stairs, for example, was recognized like wall. So it's also, for example, you can take, for example, stairs up. For true value, it's stairs up, and for neural networks, more than 140. So here we can see the result, and also some stairs was recognized like wall, and also for stairs up we can see that some stairs up was recognized like wall. You can see that such classes can be closer, or depends of the how we have the vision of it. So depends of the data that was received in the such moment. So sometimes it can be say you that it's walls, and also stairs up just few was desired like border. So here, and what, for example, with glass, it works very well. You can see that just one was for one glass, it was said that it's wall. All other was recognized correct. And also such matrix, it makes sense to make for both validation and test your data set. So of course we also do it for both. Here I just show you to present how it can be works and how to understand what's written on such matrix. And also depends of you can use it and generate it by TensorFlow. It's also I was use the Python, and it's automatically generated after each relearning, and we can set up such range where you can see depends of the color how good it works. Okay, and we can go to the next. And it's here you can see the model accuracy for both training and validation dataset, and how our accuracy growing for each epoch that we have. Also, when we starting learning, we have amount of epoch, and after some value, it's usually not helping you so much. So to grow with our accuracy. So here you can see that for us, like 6 epoch, it was enough, and how growth depends of how many learning epoch we had, then our accuracy was grow. And loss, so it's amount of errors that we have, it also depends of epoch was going down. So you can use it to validate your model, and it will be show you well. Also, here I would like to tell a little bit about so we can create firstly such matrix, and after using such true positive, and false negative, we can calculate our metrics. And one of the most popular and that usually we are calculating is precision, recall, and F1 usually score. Here you can see how such formulas for such metrics and how you can use it. And also here I add some example of dataset. It can show you why it's not enough for metrics. Just, for example, use that you decide correct to the common amount of the data in our data set, because we should pay attention as well to the if it's data balanced good. For example, we have 2 classes that balance it quite well. It will be good data set, and we will understand that it works well. If we will have, for example, from the start, or you will create not correct way your training validation data set, and your data will be unbalanced, then it can be issue. And for example, you would like to understand if such user came to your site and it's bot or it's fraud, and you can know that 98, for example, percent it's not a fraud, and just 2 is fraud. And if your model will give always like 100% that it's not a fraud, in real it will be not good prediction, but it will have very good accuracy. So it's why we need to use more complicated metrics. First of all, things about balanced data from the start. The second one is use our metrics correct way. And here you can see the results for our our projects, and it was you can see different metrics give you a little bit different value. So one, it's mean like 100. So you can see that, for example, precision show you that stairs up 100% always goods well and recognize correct. But if you see also recall and F1 score, usually one score it's like most useful metrics, because if you come back here, you can see that it's contain already precision and recall. So you can, it's something on the middle you will receive, and it will use both. And here you can see that how it works. And we have very good prediction, so it more than 90%. So, and here you can see amount of examples that we was used for such train. It's not just for train, it's already that we had in validation or training dataset. And also you should make such metrics, such table for this metrics, or make just use, for example, just one of them for both for validation and for test data set. And here we can go to the conclusion that the machine learning system development cycle has the same stages as most other software, but however, our discovery phase takes definitely more efforts because we need to research and prototype. We need to understand technology. We need to think about collecting data. And already from the start, we should understand some main things in infrastructure that we would like to have. Should we use cloud? Should we use some different way? Should we have some services inside? And of course, it will require some experiment from the start. Then you can show that it will be works, and we have some minimum data that we will use, and you can understand that data that you takes will work well. So yes, at the end, you can understand that it takes more efforts, but it will give you a lot of success at the end. And then would like to say thank you, everyone. And if you have questions, you can ask it right now or during my speech in our chat, and I will try to cover most part of them. And of course, you can reach out to me after if you have some additional one.
Well, Nastia, thank you so much for being part of the conference and for sharing the topic with us. Actually, the topic is very interesting, and we do have quite a couple of questions. I don't know whether we will be able to go through all of them. However, the first question that has been raised by our viewers was, what would you do and what happens when you discover that the data that you have in the Excel sheets, in the CSV files, and in the database is a mess, and a lot of information is missing or is mistyped? How do you proceed in that situation?
Mm-hmm. Yeah, it can happen. As I mentioned, it can be that we're receiving data from different sources, and our goal to have a clear data set. We can use as much amount of data sources as it's required, but we should understand most tricky parts, that you should understand that which parameters will be useful for your model and which not. So you will go, for example, as I mentioned, for our project, we used firstly measure the signal and amount of such signal. It was not enough for us to understand where it's in the space collected. So we also added head map, but also experiments that we done firstly with signal and how high such signal going. It also was useful because of it we was able to identify after if it's wall or it's glass, because for example it looks the same because it's some space behind of person, but some obstacles behind of person, but it have fully different high of such signal. So you can, of course, you should normalize it. So you can collect it. For example, you should choose how you will proceed with it. Probably it can be help you, depends on the data, of course. It can be some database that you can collect all of necessary parameters for you. So it also can be that you can some images inside it. So if you need to have not just text data, for example, if it's just text data, you can use CSV, or you can write, for example, for our example, it also was that we use Excel spreadsheet. To each of spreadsheet was collected different obstacles and a lot of example of it. So it was very useful to use it, because from this, and we write the scripts that we collecting take such data and after process it. So depends of the data, you can choose most suitable for you, and probably it will be databases help us with it a lot of. But if you have just, for example, text data, you can use CSV files, and its process of your learning will be more faster, and such data will be exploding from such file more faster. I hope I answered to this question. Can you hear me?
I can hear. Sorry, I was muted. Yes, so thank you so much for answering this question. However, we have more questions to go through. And another question that was raised by our viewer is from the BA and product owner point of view, what skills do you think are essentials for the machine learning projects?
Mm-hmm. It's a good question because I also have experience as product owner. From product owner perspective, of course, you should have vision. You should have understand business needs for machine learning model, and understand where it's suitable to use it. Because a lot of things that right now, for example, you use some algorithm, just write and this if else can be changed to the machine learning. And it will be give you a lot of success in the end, because if you're on the product owner role, you can understand full vision, and it will be very useful for the whole team if you will understand which business metrics we would like to measure in the end, so which the business KPI we would like to achieve. For example, it should be some additional, for example, if it's recommendation system, and we will have propose additional products to the end customer. What would like we to achieve? If we would like to have a few, how many persons should use such recommendation? How many of them or they would like to take just one additional product that was recommended. For example, we recommend 5 and they takes one, or you would like to sell them at least few, or it will require additional revenue. So maybe you should sell some more cheaper products, or you would like to sell end customer more expensive products. Or if it's also recommendation, you can take data from previous past of the user. It depends of his history, propose him or more expensive or more cheaper, and it will be have impact to the end revenue of your product as well. So if you will have vision from the product owner perspective, from the business perspective, it will be very, very useful. And also will be great if you have technical understanding how it works. Will have understand technical metrics that, like I mentioned, sometimes you can see that we have 90% correct answers from our networks. But in real, it's not. It can be just that most part of the request. So we have not balanced data, for example, for that from the start, or we had responses. We have not balanced data, or we use not right metrics. So if you understand from technical side this, you will be understand if it works well or not, and how we can improve it. And make next circle, for example, of development and improve it very easy.
Okay, thank you so much. And cautious of the time, we just have time for one last question. Some of our customers, they might be switching to Agile because Agile is a fancy word and everyone is Agile. Some of the customers want to use Jira because everyone is using Jira. Some of the customers might want to move to machine learning because everyone wants to use machine learning. How to tell the customer whether they are prepared, or especially if they are not prepared to use machine learning, how to push back on the customer?
Yeah, it's a good question. In real, machine learning can be used for a lot of tasks. And here you can, of course, understand and measure what in real they want, which type of such machine learning, and if they really need it. You can calculate which. It's also very useful for discovery phase, because you on such stage you collaborate with client a lot, and you can understand their needs. Probably, it can be cases and they need some easy automation instead of it, or maybe they really need to use machine learning, and it will be achieve their goals. So here, best way is go to their client and speak with them fully trustly, and measure what they would like to achieve, why they would like to have it, which goals from business perspective they would like to achieve, which profit it will give them. And at the end, you will, I'm sure that you will receive great feedback, and you can, following the statement of such their pain, you will propose them very best way working solution. It can be machine learning or not, and depends of I'm sure if you will cover their pain and what they feeling and how to decide such problem, you will be very successful.
Once again, thank you so much for providing a great answer to the question. And thank you once again for being part of our today's conference. For everyone who is watching us online or watching this recording at the later time, be also sure to check other presentations and other topics that we had in the BA Excellence Day. And Nastia, thank you once again so much for being part of this event, for finding the time to make this presentation, for sharing the knowledge and experience with us. It is greatly appreciated, and it has been a great pleasure to be the moderator of your session today.
Thank you a lot.